is your Unit 2 end of unit study guide. For number 1, it reads, for the following statements, determine whether they are true or false. If they are false, state why they are incorrect on the line provided. So make sure we do that part too. Okay, the first bullet point. After a dilation, the length of a line segment always stays the same. Well, that would have to be false. And then you have to write your reason. The reason it would be false is the length of the line segments would either increase or decrease on a dilation. The second bullet point reads, when dilating a figure, the angle measures always stay the same. This would be true. The angle measures inside a dilated figure always do stay the same. They're congruent. Number 3, dilations always make the figure larger. That's going to be false because sometimes a dilation will reduce the shape of the figure or the size of the figure. So that one is false. And let's put our reason. So there's a reason there. A dilation can make a figure smaller when the scale factor is less than 1. And the last bullet point, the scaled copy of a figure is sometimes congruent to the original. I would say that is true because the scaled copy could enlarge, could reduce, and sometimes it could be the same size as the original figure. Okay, moving on to number 2. Name 2 characteristics of similar triangles. So for triangles to be similar, they would be the same shape and they would have the same, or also known as congruent, angle measures. And another characteristic you could have mentioned is the side lengths could be proportional. So I'll add a note of that too. Okay, moving on to number 3. Select all of the similar triangles based on the information. And then there's a suggestion here that a drawing might be helpful. So I'm going to go ahead and do that. Triangle A has a 40-degree angle and a 75-degree angle. Triangle B has a 75-degree angle and a 65-degree angle. So I'm going to make some space over here to draw that out. Okay, so triangle A is 40, and then we have 75. Okay, so I know how from our last unit to get that third measure, we would add those together and subtract from 180. Okay, and that means that that third angle is 65. Aha. Okay, so then that's for triangle A. Triangle B has 75 degrees and 65. So triangle B is going to have the 75 and the 65. So that means that that third angle would also be 40. So if all 3 angles in there are congruent, then we would say that this pair is similar. All right, let's try letter B. Triangle F has a 55-degree angle and a 100-degree angle. Okay, so let me pause and draw that. So I'm going to put this one over here. Okay, so now, knowing the triangle sum theorem, if I add those together, that's 155. So 100 plus 55 is 155. And then I'm going to subtract from 180. Okay, so that is 25 for that third angle. Okay, and now it says triangle G is 135. Well, I know that's already going to be not true because the missing angle here is 25. So these are not going to be congruent. Moving on to letter C, Triangle 1 has a 90-degree angle and triangle 2 has a 90-degree angle. So I'm thinking here that these could be similar, but based on the information provided, we need to know one more angle. So I don't know for certain that those would be similar. I would need another angle to see if I need to know that all three angles are congruent. And then finally, triangle 3 is isosceles and has a 50-degree angle. Triangle 4 is isosceles and has a 50-degree angle. Oh, okay. So those, let me think about this. Isosceles means two angles are the same. So let's see, if we had 50 here, and then these two are the same, that would be 180 minus 50, which would be 130. And then I'd have to divide 130 into two equal parts. So that would be, these would both be 65 each. Okay, triangle 4 is isosceles and it has a 50-degree angle. I mean, if it's isosceles and it has a 50-degree angle, it would also look like this. So I'm going to say yes, these are similar, same degrees, same three angles would have the same degrees. Okay, and then vocab check. Let's try to fill in these blanks as best as we can. Okay, well, the first one's going to be similar. Similar figures have corresponding blank and proportional corresponding blank lengths. Let's say congruent, corresponding angles, all three angles have to be the same, and proportional corresponding side lengths. Okay, so all three angles have to be the same and the side lengths have to be proportional. Okay, number 5, determine which triangles are scaled copies of triangle A. So let's look at the properties of triangle A. So if I'm looking here, it looks like it has a height 1, 2, 3, 4, 5, 6. So the height is 6. And then the base here is 1, 2, 3, 4. So the base is 4. Okay. Now, let's use that information to study the rest of these. So here, this height, 1, 2, 3, 4, 5. The height is 5, and it looks like the base is 1, 2, 3, like almost 4, maybe 3 3/4. So that doesn't seem to be in proportion with 6 for the height and 4 for the base. So I'm going to say that it's not similar to triangle B. Okay, triangle C now could be a reduced figure. And if it's rotated, depending on how you look at the shape, I could say if I turned it and 1, 2, 3, I think consider this the height. So 3 for the height. And then 2, that's again, if I turned it, 2 for the base. Then that would be similar to a height of 6 and a base of 4, because 6/4, that could reduce to 3/2 for the base, so that would match. Again, that's considered if I rotated the triangle. And let's take a look at triangle D. So again, with this idea that this shape rotated, and now this being the height, let's count that up. 1, 2, 3, 4, 5, 6, 7, 8, 9. The height is 9. So for this one, the height is 9. and 1, 2, 3, 4, 5, 6 for the base, if we think of it being the figure being turned. And then if I simplified that, it would simplify to a height of 3 and a base. Let's see, simplify 3 and a base of 2. So I think that this also could be considered similar. All right, moving on. For number 6, below are polygons. Which polygons are similar to polygon A? All right, so let's look at the dimensions of polygon A again. The height, 1, 2, 3, 4. So we have 4. And then we have 2 here, 2 here, 3 here, 2 here, 1, 2, 3, 4, 5, and 5 here. Okay, so we need all those side lengths and everything to be proportional for A. So now let's look. I'm looking right now at C, and that looks like it is an exact copy, which would be similar. It would be congruent also, but an exact copy is similar and congruent, so C would be one of them. All right, let's check B. So looking here at B, let's see, 1, 2, 3 across here, 1, 2, and 3/4. 1, it looks like 1 and a 4th, and that's 1. So I don't think this is going to be similar, because it would have to be like this side length was 2 in the original would have to be 1 in both of these. So this seems a little messed up. All right, let's try D. So D, let's see, 1, 2, 3, 4, 5, 6, and 1, 2, 3, and 3 here. 1, 2, 3, 4, just over 4, maybe 4.5 or a little bit more. This one is 3. 1, 2, 3, 4, 5, 6, 7, 7.5. Okay, so let's see. So I'm going to pick a couple side lengths to see if I can figure out the scale factor. All the side lengths would have to have the same scale factor. So I'm going to start with this 6 and compare it to the 4. So 6 compared to 4, 6 divided by 4 is 1.5. So now let's do this long side. 7.5 compared to the 5. So 7.5 divided by 5. So I'm going to grab my calculator and I'm going to do 7.5 divided by 5. And that is 1.5. All right, how about we compare this 3, which matches up with 2. So 3 divided by 2, is that 1.5? Yes, it is. All right, but it has to work for the whole figure. All right, let's try 4.5 and compare that to 3. So 4.5 divided by 3. So I'm typing that in. 4.5 divided by 3 is also 1.5. Aha. And then the last ones, we have 3. The 3 comes down to a 2. We've done that already. So D is a similar figure. Okay, moving on to E. It looks like it could be about half the size. Let's look at our side lengths here. Okay, we have 2, we have 1, we have 1. This looks like 1.5 or 1.5, 1, and then this is like 2.5. Okay, so is this all half the size? So let's see, 4 and it's a 2. Yeah, everything checks out because 3, 1.5 is half of 3. Yeah, so E would be a similar figure. Oh, D is a similar figure and E. Okay, let's move on to F. F looks completely out of whack. I don't even think I have to test it out. because look at how skinny this part is. So F is not going to be a similar figure. Okay, now part B is to choose one of the polygons that are similar to polygon A and describe a sequence of transformations that takes polygon A to the selected polygon. So here it's your choice. We're going to decide what we're going to do. So I'm going to go from A to D. So a couple things we'd have to do. First, it looks like a dilation. So dilation with the scale factor of 1.5. And then it looks like it's flipped, so we'd have to do a reflection. And we don't really have a line of reflection, so I'm just going to leave it as that. So you decide which one. I'm just going to show you A to D, but you could also say how you got from A to C or A to E. Triangle MLK is similar to triangle RQP. Show your work and answer the questions. What is the length of segment PR? So from here to here. All right, so let's use what we know to find out what we don't know. We know we have a 9 here from KL, and that corresponds to 18. So to go from 9 to 18, we times by 2. Using that as the scale factor then, 13 times 2 would get us the measure we're looking for. So 13 times 2 is 26. So 26 would be right here because the scale factor is 2. So what is the length of segment ML? Well, to go the opposite of multiplying by 2 would be to divide by 2. So 28 divided by 2 would be 14. All right, moving on. Draw the dilation of LMN with a center of 0, 0 and the scale factor of a half. Okay, so we have our original order pairs. So let's set up some space to do L prime, M prime, and N prime. Since the scale factor is a half, we're going to either multiply by a half. So I can just set this up and go straight across. So negative 6 times 1 is negative 6. And then 1 times 2 is 2. And negative 6 divided by 2 is negative 3. Okay. Or multiplying by a half is the same as dividing each digit, dividing it by 2. Okay, so 0 times a half, or 0 divided by 2 would be 0. So this would be 0. We already figured out that negative 6 times a half is negative 3. And then negative 4 times a half is the same as dividing by 2, or we can do negative 4 times a half, which would be negative 2. Okay, once I've figured out all of my ordered pairs, then I go ahead and plot those and draw the figure nice and neat. Okay, so I've plotted them all. So this is L prime, M prime, and N prime. And then you want to neatly connect those. And there it should look like it's half the size. Okay, so we need all of our ordered pairs and we multiply by the scale factor. Let's go on to number 9. Now the scale factor is 2. So everything in here will be multiplied by 2, all of these digits. All right, so E prime, negative 3 times 2 is negative 6, and negative 2 times 2 is negative 4. F prime, 0 times 2 is 0, and 4 times 2 is 8. G prime, 3 times 2 is 6, and negative 2 times 2 is negative 4. And then H prime, anything times 0 is 0, and negative 5 times 2 is negative 10. Now that I have my ordered pairs, I'm going to plot that. So to begin with E prime, you go back 6, and then down 4, and then we'll mark that E prime. Okay, F prime is 0, 0, 8, 5, 6, 7, 8, so right up here, F prime, and then G prime is forward 6, down 4, and we mark that G prime, and 0, the final point, H prime 0, negative 10, would be here, mark that H prime. And then your final step, make sure everything is labeled and neatly connect. It should be the same shape, but a larger size. Okay. The next set of questions are state prep questions. So these are questions that we've actually seen on our 8th grade state test. So these are good to look at. Okay, so similar parallelograms E, F, G, H, and P, Q, R, S are shown. Which sequence of transformations can be performed on E, F, G, H, so on this smaller figure, to prove that they are similar? So how do you go from this smaller figure to the bigger figure? Okay, so it's definitely getting larger, so the scale factor would have to be a number greater than 1. So I'm using that idea to eliminate choice B and choice D, because I know that it's going to be 3 times bigger. Now, is this a reflection and then a dilation, or a 180 rotation and then a dilation? I suspect that it's a reflection and then dilated. Here's why I think that. So if I go ahead and reflect this over the x-axis, so I'm going to put H prime would be here, E prime would be here, F prime would be here, and then G prime would be here. Okay, so here is my reflected figure. Now I want to see if each ordered pair would be 3 times bigger. So I would want to do that math. So right now E prime is 1, negative 4, and if the scale factor is 3, I times everything by 3, I would be for E would then become P, so that would be 3, negative 12, and 3, negative 12 is where P is, which reminds me, when we looked at the beginning, E, F, G, H, it aligns with P, Q, R, S. Okay, so E turned into P. And then if I do F, F turns into Q. Okay, so F prime that I did in purple there, F prime was negative 2, negative 4, and if I multiply those by 3, I get, and then F turns into Q, I get negative 6, negative 12. So Q is at negative 6, negative 12. So if I keep checking the ordered pairs, I reflect it, and then a scale factor of 3. So this one is going to be A. It's not going to be C, because if I do a clockwise rotation, then my letters are going to they're not going to align properly. So this one was close, but it's definitely going to be A, because we reflected it and we checked the ordered pairs. All right, next, let's see. A transformation is to be performed on a figure. Which transformation will not produce a congruent figure? Well, we know reflections make congruent figures, so do translations and rotations. So the only one that does not create a congruent figure is a dilation, because those create similar figures. Okay, so that's a good question that you might see. All right, Brian uses two transformations to show that these are similar to each other. J, K, L, M is similar to W, X, Y, and Z. So definitely it's enlarging, so it's going to be a dilation. So it can't be A or C. Now, is it a reflection? Did it flip or did it slide? The reason I know it flips is because J aligns with W. So J is here, and then it goes and flips over to there. And then the same thing's true for M. See, M is here, and it flips over to there. So this is definitely a flip. Okay, so those letters can help you determine if it slides or flips. Okay, and then moving on. Oh, this one's kind of an interesting one, challenging. All right, let's go step by step. Ted draws a triangle MNO in quadrant 3. So I'm going to draw a triangle down in here, and you can do that on your paper too. MNO. All right, he applies two transformations. So first, he's going to reflect it across the x-axis. Okay, so then it would look like this. M prime, N prime, O prime. Okay, then it's going to dilate by a scale factor of a third. So it's going to shrink down, but it's dilating around point M prime. Okay, so it's going to shrink down to around M prime. So it'll be a third of the size. So it's going to be right in there. But now it changes to the letters P, Q, R. Okay, I don't know if you can see that properly. P, Q, and then R. So it shrunk down inside itself. So it ends up there. Now let's read our statements. Triangle PQR is congruent? No, it's definitely similar. It shrunk down. So it's not congruent, and it's not in quadrant 4. Its PQR is congruent, and it's in quadrant 2. Almost, but it's not congruent. It's similar. Okay, here we go. It's similar, and it's in quadrant 4. I don't think so. We're in quadrant 2 right here. So it's going to have to be D. It's similar, and it lands in quadrant 2. The key to that one, I really think, was that it was dilated about point M. Okay, also understanding the vocabulary, the difference between what it means to be congruent and what it means to be similar. All right, here's another one. It says ABCD is translated, so we slide it, and we create quadrilateral EFGH. Okay, so we just take this same shape and size, and we just slide it over here or wherever. And instead of A, it becomes E. So this is E. And then B becomes F. C becomes G. And then D becomes H. So what is the length of EH? Okay, so that is right here. E to H is the same as A to D. So this is 8 units. Okay, again, you can understand A, B, C, D, E, F, G, and H. And we're looking for EH. E goes with A, and H goes with D. So it's this length right here. So 8 units on that one. All right, two triangles are shown. What transformation can be used to show that LMN is similar to PQR? Okay, so you can see that it has definitely reduced in size, so we know it's a dilation. Okay, so it can't be A or D. And then it looks like it's turned. So that would be a rotation. That one would be C. Okay, last question. Penny has a pool that's shaped as a trapezoid with lengths in feet, and Ben has an identical pool and it's rotated as shown. So it turns around. What is the length of EF? Okay, so EF right here, that aligns right there with AB. So this is 1.8 feet. Okay, again with our letters, A, B, C, D, turned into E, F, G, H. Okay, so EF, you can see based on the order of the letters goes with AB. So for sure that side length is the same as that. Okay, so that completes your review. Let us know if you're stuck on anything.